Hello everyone, welcome to the presentation of my data analysis project. The main goal of this project is to analyze the global COVID-19 epidemic data and build a machine learning model to predict the recovery rates of patients. First, let's take a look at our datasets. There are three datasets here. The first two datasets provide time series data of confirmed deaths and recovered cases by country and date. The third dataset provides country-level data, including population, testing rates, and so on. After that, I perform some general data processing, starting with handling missing values. Data cleaning also was performed by using these scores and IQR, and then normalization and standardization techniques were applied to prepare the COVID-19 dataset for analysis. Next, I visualize the dataset. To better understand the dataset, I created for visualization. First, the histogram of standardized confirmed cases shows a right score distribution, indicating that most countries have relatively low number of cases, while a few countries have experienced very serious epidemics. Then comparing the scatter plots of confirmed cases and active cases reveals a clear positive correlation. The higher the number of confirmed cases, the more active cases there are. The third visualization is a box plot of the normalized total number of cases per million population. Finally, the line chart of new cases over time captures the dynamic evolution of the epidemic. To prepare for our machine learning data and increase the complexity of dataset, I merge the datasets. After that, I introduced the time and ratio-based features to capture daily dynamics, smooth trends, and differences between datasets. Then I use the label encoding and divided countries divided countries into low, medium, and high severity groups based on the upper limit of confirmed cases. Also, correlation analysis was performed to determine which numerical features were most correlated with the recovery rate of each country. After all the preparations done, I split the dataset into training sets, validation sets, and test sets to support model training. The goal of our machine learning is to predict the recovery rates through other features. The first is the logistic regression model. While it's able to identify low cure rate cases, well, it has difficulty handling higher cure rate cases, as shown in confusion matrix. This imbalance highlights the limitations of logistic regression in handling biased cases in cure rate prediction. A comprehensive evolution on the test set shows the clear limitations of the logistic regression model. This may indicate that it often misses cases with high recovery rates. Then there is a random forest model. The test set result shows that the random forest model performs very well in the task of this training process. Then there is a neural network, and we can also see from the results it performs very well in various evolutions, just like the random forest. Finally, we can see there is a comparison. We can see that that the performance of a neural network and the random forest is very good. Thank you for watching.